Another method of solving system of linear equations is called elimination method. Now, some books do also call this addition method. So addition or elimination method, they're both the same. Now that means, as the word indicates, in this case we have to eliminate a variable. Now either we're eliminating the x or the y. This really depends on the student. Which do you think is easier to eliminate? And when we eliminate, when I say eliminate, what that means is we have to have opposites. So in order to get rid of a variable, we either have to have a plus 3x and a minus 3x. So neither one of those two equations are set up that we can just eliminate. What that means for us is that we have to change the equations first. So I'm going to eliminate the y first. And let me tell you why I picked y and not x. And you got to look out for those things because the y's already have opposite signs. That's how you eliminate a term with opposite signs. So if I pick the y, I don't have to worry about multiplying anything by a negative number. All I need to worry about now is what number do I need to multiply both of these equations by to get opposite number. And this is similar to finding the least common multiple, least common denominator. What is the least common denominator of 3 and 5? That would be 15. For the first equation, I already have a 3, so to get to a 15, I need to multiply every single term in the first equation by 5. So I usually put a little arrow there and write times 5, but sometimes I write it like this as well, so we don't forget the number on the right-hand side. Multiply everything by 5 is 30x minus 15y equals negative 15. Okay, there's my 15y. Now the second equation, I already have a 5y and I need to get to a 15y. So in this case, I need to multiply every single term by 3 times 3 times 3 times 3. That gives me 4 times 3 is 12x plus 15y equals negative 27. Okay, we have opposite terms now. We can eliminate them. How do we eliminate? We add them. And that's why it's sometimes called addition method, because the next step is to add. 30x plus 12x is 42x. The 15y's, that was our whole reason why we did that, cancel out. And on the other side, we have negative 15 plus a negative 27, and that is a negative 42. Ooh, this works out fairly nice. Divide by 42, both sides, to get x by itself. Negative 42 divided by 42, the answer is x equals negative 1. This is our first value. Don't stop here. You also need to find the y value, and to find the y value, you want to substitute it into one of the two original purple, in this case, equations. So again, try to be smart about it. Look for signs. Do I have negative, positive, smaller numbers? In this case, it doesn't really matter. I'm going to substitute the x equals negative 1 into the second equation. And that way I'm going to find y. 4 times x, x is negative 1, plus 5y equals negative 9. 4 times negative 1 is negative 4 plus 5y equals negative 9. Add 4 to both sides. 5y is equal negative 9 plus 4 is a negative 5. Oh, look at that. Divide by 5. Oh, have no more room. Y is also equal to a negative 1. Negative 5 divided by 5. Therefore, our ordered pair is negative 1 comma negative 1. We get one solution, which is our first case here, where the lines, if we were to graph them, intersect. Here's another systems of linear equations we want to solve by elimination method. Elimination method, you have to eliminate one of the variables. Let's take a look here. We have a negative x and a 3x. So I'm deciding, they have opposite signs. I'm deciding to eliminate the x. Now, I already have a positive 3x in the bottom, which means the top equation has to be multiplied by 3. Each single term multiplied by 3. I don't have to worry about a negative sign because I already have that here. 3 times negative x, negative 3x, plus 3 times 3 is 9y equals 18, 6 times 3. The second equation, I'm just going to bring over. I do not need to make any changes. 3x minus 9y equals 9. Now comes the eliminating adding part. So what happens here? Negative 3x and a positive 3x cancel each other out. Oh, look at that. 9 and negative 9y, they cancel each other out. The left-hand side, I'm left with 0. And on the right-hand side, I get 18 plus 9. 18 plus 9 is 27. So my variables all canceled out. I have 0 equals 27. Is that really true? No, that's not true. That's a contradiction. When this is the case, when you have your variables canceled out and that is equal to some kind of number, we get our parallel case. Here the lines, if we were to graph it, are parallel and we have no solution. This is our second case with no solution. Let's solve this system of linear equations by elimination method. Yes, we do have fractions, which I call fraction action. We need to clear the denominator here. That makes it way easier for us. So in other words, we're looking at the first equation and we have to find the least common denominator, and the least common denominator of 4 and 2 is indeed 4. We're going to multiply each term by 4. I'm going to write 4 over 1 so you know how to reduce this the proper way. Why do we do this? To clear the denominator. 4 goes into 4 one times, which leaves me with, let me write it down here, 3x. Now I'm going to the 5 halves times 4 over 1. 2 goes into 2 ones and into 4 twice. I've cleared the denominator. 5, don't forget this 5 here. 5 times 2 is 10y. Now that is equal to, there's nothing I can reduce, so I just multiply 11 times 4, which is 44. Now I'm looking at the second equation, and I do the same thing with finding the least common denominator of 16 and 4, and in this case that would be 16. So I multiply by 16 over 1, 16 over 1, and by 16. Again, to clear the denominator, 16 goes into 16 once. 1 times x is x, minus 4 goes into 4 once and into 16 4 times. Don't forget this 3. Minus 3 times 4 is 12y. And Here there's nothing to reduce, so we're just multiplying negative 16. This is our new system of equations. If we solve this by addition method, we want to now see, okay, which variable is it that I can eliminate? Which one is easier to eliminate? And if you look at the y term, you see you have a 12 and a 10. They have nothing in common, so I would have to change both of these equations. But if you look at the x term, we have a 1x and a 3x, so that is perfect. We're taking the second equation, we want to eliminate the x, and we do so by multiplying each single term by, I already have a positive 3, so in this case I would need a negative 3. Negative 3. So negative 3 times x is negative 3x. Negative 12 times negative 3 is positive 36y. And negative 16 times negative 3 is a positive 48. So I changed the second equation and I multiplied everything by negative 3. The top equation, I just copy over. There's nothing I need to change. Plus 10y equals 44. So I'm going to add both of these equations. I can eliminate the x's. 10y plus 36y is 46y, and 44 plus 48 is 92. I divide this by 46, 92 divided by 46. You either use your calculator or you know that 92 divided by 46 is 2. Y is equal to 2. Now you need to find your x value. I'm going to plug in the the y value into my green. I need to find x, not y. I'm plugging in the y value into the green equation, replace y with 2, and that way I can find x. X minus 12 times 2 equals negative 16. I have no more room, but I can. X minus 24 equals negative 16. Now to get x by itself, I'm going to add 24 plus 24. X equals negative 16 plus 24 is a positive 8. Beautiful. Here you go. Our ordered pair, in this case, they do intersect at one point, is 8, 2. This was our fraction system of equations. Let's take a look at systems of linear equations. What does that mean? Well, that means that we have more than 2 equations, or actually 2 or more. Can I start again? 2 or more. I didn't want to say. Yeah. Okay, I'm ready. Let's take a look at. Okay, I'm ready. Let's take a look at systems of linear equations. System of linear equations have 2 or more equations. It really all depends on the amount of variables that you are looking for. We are looking for a system of equations that have 2 variables, so I have an example right here. They can be solved either by graphing, by substitution, or by addition method. Today I want to show you how to solve by substitution method. Now when we're solving those systems of linear equations, usually our solution comes in form of an ordered pair x, y. So that happens real quick is if you have 2 lines, when they intersect with each other, that would be your solution, and this is in form of an ordered pair x comma y. Now this solution has to make both of these equations a true statement. If it doesn't work for one, then it is not a solution. Now something else can happen when you solve these linear systems. What can happen, it's better to show you graphically, if you have two lines and they do not intersect at all. They are parallel. If this is the case, if you have parallel lines, they do not intersect, so that would mean you have no solution here. A third case you could come across with, if you have two equations that look different, but however, when you graph them, you will see they are exactly identical. They just look different. Those are equivalent equations, but the graph is the same. When that happens, the lines coincide. It's called coinciding, and you have infinitely many solutions. Of course, the most common one is actually where the lines intersect and you get some kind of ordered pair. But be careful, sometimes you have no solution and sometimes you have infinitely many solutions. So let's go back to this problem. We want to solve this by substitution method. When you solve by substitution method, one of the variables always has to be isolated. So it either should say y equals or it will say x equals. In this case, this setup is beautiful. We already have y equals. Now we can just make this name proud and we can go ahead and we can substitute. We are substituting, we're replacing the y with x plus 2. Because, why do we do this? We can only solve an equation with one variable. So we try to change our equation into one variable. 3x stays the same, minus 2 times y. However, y is being substituted with what? X plus 2. And now finish up equals -5. So this is our new equation, and you can clearly see it has only one variable. Now we solve this equation by our conventional solving equation rules. 3x, we need to clear the parentheses and distribute the 2, but don't forget this is a -2, so we can just look at it as -2 times x, which is -2x, and -2 times +2 is -4, equals -5. We cleared the parentheses, combine like terms. Which ones are like? 3x minus 2x, beautiful. 3 minus 2 is 1x, minus 4 equals -5. The only step left is to add 4 to both sides, which leaves us with x equals -5 plus 4 is a -1. Now do not stop here. Since we have a value for x, we also now need to find the corresponding value for y. And how do we do this? We go ahead and we substitute, and we're substitute into the equation that says y equals, we're replacing the x with -1, -1 plus 2. Beautiful. -1 plus 2 is indeed 1. So we have found the point where the lines intersect, and we want to write this as an ordered pair. The last step is write it as an ordered pair. X comes first, -1, comma 1. Done you are. Let's solve this system of linear equation by substitution method. For substitution method, one of the variables has to be isolated. That needs to be our first step. So one of the variables needs to look like x equals or y equals. You have to decide which one you think is the easier one to rearrange. Here we don't have the setup. So one of these equations has to be rearranged. And if it is me who's doing the problem, I would go with the first equation. And you want to look for the variables being by itself. In other words, the coefficient is 1. So the only place where I see a coefficient of 1 is right here, minus y, this term. So I want to solve for y, the first equation. That means the first step is to subtract a 2x from both sides. Let me continue down here. Be careful. This one says negative y. Negative y equals, let me write the x term first, negative 2x minus 1. Am I interested in negative y? No. You have to change this to positive y by dividing by negative 1. All three terms. This becomes y equals, negative divided by negative is a positive 2x plus 1. So now I have accomplished my goal of isolating one of these two variables for either, in this case, y. What do I do with it? I'm going to substitute the y in the second equation with 2x plus 1. Why do I do this? To get an equation with just one variable. So now I'm copying the second equation, 5x plus 4, but the y is being replaced with 2x plus 1, and that is equal to 17. So this is now the equation I have to solve by clearing the parentheses first. 5x plus 4 times 2 is 8x, 4 times 1 is 4, equals 17. 5x plus 8x, combined like terms, is 13x, plus 4 equals 17. Subtract 4, because we want to solve for x, and look how beautiful this is here. 17 minus 4 is 13. Divide by 13. X equals 1. Beautiful. Now we just have to find y. How do we do that? We're going to substitute again the x equals 1, and you substitute it into the equation that you have solved for y. That makes it easier. Y equals 2 times x, x is 1, plus 1. 2 plus 1 is indeed 3. Y is equal to 3. Our ordered pair, in this case, again, this is a case where the lines do intersect, and the ordered pair would be 1, 3. Just like so. Here we have another systems of linear equations, so let's solve this one by substitution as well. As you can see, we do not have to isolate here because our first equation already says y equals, so the setup is perfect. All we need to do here is substitute. We're replacing the y in the second equation with 2x minus 5. So let's do this. 8x minus 4 times y. Y is, in this case, 2x minus 5. We're substituting the y, and then we continue on with the second equation, and this is equal to 20. Solve this equation. Distribute and clear the parentheses. 8x minus 4 times 2 is minus 8x, and we have a minus 4 times a negative 5, which is a negative 20, and that is equal, oops, that is not a negative 20, that is a positive 20. -4 times -5 again, -4 times -5, positive 20, and that is equal to 20. So let's see what we can do. We combine like terms. 8x minus 8x, no worries. Yes, indeed, they do cancel out. That does happen sometimes. And what we are left with here in this particular problem is 20 equals 20. Now here on the other side, on the right-hand side here, are our three cases. We don't have a variable, so we're not solving for x and y in this case. They do not intersect at just one point. What happens is when the left-hand side is equal to the right-hand side, basically an identity, which means this would be our third case here, and we have infinitely many solutions. So if your variables all cancel out, and no worries, this does happen, then you have infinitely many solutions if you have an identity, what you're left with, if the left-hand side is equal to the right-hand side. That's the case here, which means the lines, if we were to graph that, would be exactly identical. They do coincide. They may not look the same, but if you solve this second one for y, you will see they reducing, and it actually will be exactly the same as the top one. Infinitely many solutions.